Welcome everyone to a video where we take a look at how we can build a character movement like this one and how we can add these animations. So this is how the game runs and this is what we're going to try and build this episode. So we got a simple camera following system, we got some simple walking animations, and obviously we have running and jumping. Okay, so here's our fresh script and I've already added a requirement type of character controller and let's immediately import it. So to import it, you might know the syntax is very simple. It's private character controller and you can name it whatever you want. I'll just name it character controller. Okay, so after you define it, we obviously need to instantiate it. So to do that, we're going to need a start method, and in the start, we're going to instantiate it. So like in here, and now let's define some new variables. Okay, so let's define them public for now and let's call them speed. So we have walk speed, we have run speed, we are going to have a jump force, and let's keep it simple with these three for now. After that, we are going to need some kind of a input, and to get inputs, we are going to use a float variable. Okay, so I've defined a move Z and a move Y. And you might have guessed it, this is going to represent the horizontal and this is going to represent the vertical axis. And now in order to use it, we're going to use a fixed update. And just to keep things simple, we are going to define another function. Okay, now we have a movement method. Let's populate this method. So the first thing we want to do with this movement is we want to tell the character controller to move in a certain direction. And if we try to say character controller dot move, we're going to see that it takes in a vector3 parameter. So let's define a vector3 parameter in here. Let's say private vector3, and for now I'm just going to call it move. And after we define this move, we can just straight up feed the character controller that move right here. So now we have no more errors. Let's work in this move function. So in order to move, we obviously need some input from the keyboard, and if you want the mouse, I'm not going to use the mouse, I'll just use the keyboard. Okay, now let's use the move Z and the move Y. So you might have guessed it, the move Y will be equal to input dot get axis dot horizontal. Okay, now we have the move Y as a vertical and the move Z as a horizontal. Now all that's left for us is to use those movements. Now before passing this move vector in here, let's give it some values. So let's say move is equal to, so the first parameter we're going to give is called transform dot right, and we don't just want to give a random right, we want to multiply it with this movement right here. So transfer dot right times move in the y direction. And what we can do in here is we can add in another transform. So we're going to say transform dot forward, and we're going to multiply the forward with the move Z. Okay, now this should let us move our character. Let's save it and let's see if it works. Okay, now we're in the play mode, and if we try to move forward, we're going to see that the player is actually moving forward and sideways. It's moving a little bit quick, as we can tell, but it's moving. Okay, now let's improve the movements. Okay, before we proceed on improving these movements, let's go ahead and define a function that will let us know if we're shifting or not. So later we can use it to run or walk. To do that, I am going to use another private boolean, and I'm simply going to call it shifting. Okay, this is a very oversimplified if statement, and all it does is it sets this shifting if we're pressing the left shift. And if we're not, this is obviously going to return a false value, so shifting now is taken care of. Okay, since this move Z vector is responsible for the vertical axis, we want to kind of improve it. And to improve it, first we want to know if we're shifting. So in front of this expression, we are going to say just shift. And this is of course another if statement, but it's a little bit simplified. And now in here what we're doing is we're asking if we're shifting. So if we're shifting, we want the vertical axis to be equal to obviously the input vertical times the run speed. And if we're not, that means these two dots in here. So if we're not, we want to pass this exact expression but multiplied with walk speed. So now we know if we're running or walking. Okay, so what I've done in here is I've defined the walk speed at 0 0.1 and run speed at 0 0.5. So what I'm going to do now is try to walk, and we can see we're walking at a constant speed. So if I press shift, it's going to walk faster or run. And we can obviously move right and left. Okay, now let's add a function that lets us know if we're grounded. And before we do that, we want a function to add gravity to this controller. And if we don't do that and we place our character somewhere above the ground and hit play, we're going to see that he is going to float, like right here. We can see that he is floating and he's going super quick. Okay, so to implement those physics, I'm going to define a new method in here and I'm going to simply call it physics. Okay, into the physics, we want to do some math equations. Okay, the one thing that we want to know from the physics is the grounded function. So back where we have this Boolean shifting, we're going to define another Boolean and we're going to call it is grounded. And now we're going to do something similar to what we've done in here. And the line is grounded is equal to physics with capital P dot check sphere. So this is another raycast function that checks the sphere as we can see in here, and it takes in a vector3 position and a radius. So for the position, we are going to just give it transform dot position, which means our own body. And for the ground distance, I'm simply going to just hard code it to 0.4f. And now this should give us a function that lets us know if we're grounded or not. Okay, so what I've done in here is I've added a GUI function that lets us know if we're grounded without having to check our scripts. So now that we know if we're grounded or not, let's implement a gravity function. And to do that, it's actually not that complicated. So for the gravity, we are going to need one more vector3 and we are going to define it up here. And I'm just going to call it velocity. And since the gravity works only in up and down function, we want the velocity to work only with the y. So velocity dot y plus equal to. Okay, so in here we are going to need an actual gravity float so we can vary the gravity, and I'm going to define it up here. I'm going to call it public float gravity. After having defined a float called gravity, down here we are going to say velocity dot y is plus equal to gravity times time.delta time. Okay, so before we apply the gravity into the character controller, we need one more if statement. And in here we are going to ask if we're grounded, so if is grounded, and the current velocity is less than 0. So we're going to say velocity.y is less than 0. And the only thing that we want to do if this expression is true, we want to set the velocity to -2. Okay, now we're done with the gravity, and all that's left for us to do is to apply the gravity into the character controller. So you might have guessed it how we're going to do that. We're going to just say character controller dot move, and we're going to pass in the velocity. Okay, now we have a physics system, and if we save this and go back into our game, we should have a falling system. So let's see if it works. Okay, we can see that nothing is happening, and that is because we have 0 gravity. So if you want the world gravity, it's minus 9.81 if I'm not mistaken, but for now I'm going to pass in minus 15. And as we can see, we just fell to the ground and we're moving supersonically quick. Okay, perfect. Okay, now let's define one more function, the jumping function, and that is rather simple. So we're going to define it down here. And to do that, we are going to use another axis. So we're going to ask if input.axis, the name of the axis is called jump with capital J, is not equal to 0. That means we're not pressing the jump button. And in here we want to modify this velocity.y. So we want to say velocity.y is equal to mathf.square root. And in here we get to use our jump force. So we're going to say jump force minus 2 times the gravity itself. Okay, this is our jumping function. Here is how jumping works. We can jump super high. We can always decrease the jumping force, and we're falling super quickly. So maybe we want less gravity. But as we can see now, we can jump infinite amount of times, as we can tell in here. So the way we're going to fix that is by asking if we're grounded, and if we're only grounded, we can jump. So that's a very simple fix. So we could just go into this if statement and pass in if we're grounded or not, but usually if we're grounded, we cannot move at all. So instead of making it impossible to jump, we are going to make it impossible to move at all. So before the movement, we are going to ask if is grounded with a exclamation mark. So this means if we're not grounded, we can move. If we are grounded, we cannot move at all. Okay, so that is the basics of the character controller script that I wrote. You might find another version of it. And for the last part of this tutorial, we are going to try and animate this. So what's unusual about my animation is that I'm using obviously mixamo.com for my animations. So what's interesting about this is that I am using a 2D freeform directional. So what this means is that here, if we play this, we can see what is happening with my character. So I've defined a speed and a direction. So if y speed becomes to half, like right here, for example, that means we are walking. So after we're walking, we can adjust the direction like we see in here, and we can obviously make him run and still adjust the direction. So I'm not gonna bore you off with this formula because it's quite simple actually. Here it is. You can just copy it for yourself, and you can obviously download these from Mixamo. I've done a tutorial in my last video. So all I'm gonna show right now is the animation with scripting. Okay, so having spent a lot of time trying to improve this code, I've added some lerp functions so it doesn't just instantly accelerate, and I've added this animate. So it's a very simple function, and I've added another lerp in here so it doesn't snap in between animations. And we obviously have these two floats, so we jump between them when we want to. And obviously we'll lerp from the speed into whatever we want. So in here we have shifting, that means we're running, and we have walking. And up here what I've done is basically the same thing. I've added a little bit of momentum using another lerp function, and what I've added is another set boolean jumping, which is another state you can add in right here. So we have a transition that has no exit time and another transition that also has no exit time. So it's very simple. So here is the final product right here. So we have these animations that I just told you. We can jump obviously, and it's very nice and smooth. So we can transition between animations very nice and smoothly. Okay, so thank you for watching. If you have any suggestions, please do drop them down below in the comments down below, and I'll see you in the next videos.